At 2:43 a.m. on May 24, 2025, 3 Ukrainian strike drones sliced through the darkness over the occupied Zaporizhzhia Oblast. Their target, one of Russia's most critical logistical lifelines, the Verhin-Tokmak-Melitopol railway line. Rolling down the tracks that night was an 8-car train carrying approximately 560 tons of fuel, enough to support 2 Russian battalions for a week. But what the Russians didn't know was that within 60 seconds, this fuel would be burning in the Ukrainian countryside, not inside Russian tanks. This coordinated strike involved 5 distinct drones working together seamlessly. As seen in the footage, a DJI Mavic 3 reconnaissance drone provided overwatch and target identification from 8 kilometers away. 3 Ukrainian-built FPV quadcopters were assigned for the actual strikes, while a second, DJI Mavic stood by as a backup in case the primary recon drone was compromised. But these aren't your average drones you'd find on Amazon. The DJI Mavic 3 platforms, modified by Ukrainian engineers, often come with field-enhanced specs. Their stock Hasselblad L2D20C camera includes a 20-megapixel sensor with up to 28x hybrid zoom, and with custom firmware tweaks, they can extend the digital zoom up to 56x. Some units are even retrofitted with FLIR boson thermal cores, allowing thermal reconnaissance and heat detection at night. These drones cruise at 68 km per hour, have a 46-minute flight time, and can operate at altitudes up to 6,000 meters. In contrast, the Ukrainian FPV strike drones are optimized for one-way missions. Equipped with 7-inch propellers on 2 807 class brushless motors, each delivers 2.5 kilograms of thrust, tuned with F7 flight controllers running custom Betaflight firmware. These drones can dive at over 140 kilometers per hour, maintaining stability even during high-speed impacts, making them one of the most effective low-cost strike weapons in modern warfare. From a secure command center located 30 kilometers away, Ukrainian drone operators monitored the thermal feed. Suddenly, a distinct heat signature appeared, bright and unmistakable against the cool landscape. The Mavic 3's thermal sensor can detect temperature differences as small as 0.05 C at a range of 200 meters. This reconnaissance platform had been specially modified with firmware to evade Russian aeroscope detection systems, which typically track DJI drones via their unencrypted signals. Through encrypted comms, the lead recon operator confirmed visual on the fuel train. The locomotive's diesel engine glowed intensely in the thermal spectrum, making it an easy target, even in total darkness. The recon feed streamed all this in real time to the strike operators. 3 FPV pilots received the targeting data via encrypted links. Each drone likely carried a 2.66 kilograms shaped charge warhead, like the one shown here, designed specifically for single-use precision strikes. These warheads feature dual-stage detonation systems and are made from hardened steel tungsten alloy, capable of punching through 22 millimeters of armor, easily penetrating the 10-15 thick walls of standard Russian fuel tank cars. Upon detonation, they generate explosive jets traveling at over 30,000 feet per second, igniting fuel contents at temperatures above 2,500 C. But there's another critical, often overlooked element to this strike: timing. Ukrainian intelligence had been tracking this fuel train for 72 hours, using a network of partisan spotters, armed with nothing more than smartphones. They mapped out its refueling schedule, average speed, and most importantly, the 15-minute window when the train would be furthest from Russian air defense coverage. These partisans, ordinary civilians living under occupation, risked their lives to provide the targeting data that made this mission possible. With both visual and electronic confirmation, the first strike operator initiated his sequence. His quadcopter dove into a shallow attack run. Navigation was handled by encrypted GPS signals, but during the final 15 seconds, the drone switched to optical guidance, using advanced image recognition algorithms for terminal precision. This dual navigation system ensured maximum mission effectiveness. The Mavic handled surveillance and target designation at a safe distance. The FPV drones executed the strike with pinpoint accuracy and minimal exposure, but hitting a moving train is far from easy. The train travels roughly 11 meters per second, requiring exact timing and trajectory. The drone's fixed mount camera, equipped with digital stabilization, kept visual lock throughout the approach, even as the vehicle danced over the tracks. At exactly 2:44 a.m., just as the first drone entered its terminal dive, something unexpected happened. 3 kilometers away, Russian Lear-3 electronic warfare is system activated. Mounted on a KAMAZ truck, the Lear-3 carries jamming hardware capable of disrupting drone GPS and control signals within a 30 kilometers radius. It locked onto the drone signal and blasted broadband jamming across multiple frequencies, trying to crash the drone or force a retreat, leaving it open to Russian artillery fire. The operator's interface began flashing warnings, connectivity dropping rapidly. The Lear-3 system escalated, deploying spot jamming specifically aimed at the 2.4 GHz band commonly used by DJI drones. But the Ukrainians were ready. Their drone systems used frequency-hopping spread spectrum FIS technology, shifting signals hundreds of times per second across 3 different bands, making it nearly impossible for the jammers to lock on. The Mavic continued transmitting real-time intelligence, its AI-assisted software actively switching to open frequencies during jamming attempts. Even when communication dropped, the AI-enhanced sensors kept target tracking locked. As jamming intensified, the strike drone switched to its L-band backup channel, a secure link that distributed its signal across multiple frequencies, shifting patterns up to 200 times per second. The Russians tried GPS spoofing, sending fake signals to confuse the drone, but once again, Ukrainian engineering prevailed. Each drone had an inertial measurement unit (IMU) on board, accelerometers and gyroscopes that measured changes in motion, providing jam-proof backup navigation. When GPS degraded, the IMU took over, completely immune to spoofing or jamming. The drone locked onto key visual features of the fuel cars using onboard recognition software trained specifically on Russian rolling stock. Even without operator input, the drone could identify fuel tanks, calculate impact points, and complete its mission autonomously. At 2 hours 44 minutes and 30 seconds, the first strike hit. The 2.66 kilograms warhead slammed into the third tanker car, piercing its 12mm steel hull, and detonated. The secondary incendiary charge ignited the pressurized diesel, creating a fireball exceeding 2,500 C. The explosion vaporized fuel and ruptured containment systems, with the heat plume expanding rapidly across the thermal feed. Within moments, adjacent cars caught fire, due to interconnected ventilation systems originally designed for pressure equalization during loading. At 2:45 a.m., as the burning train sat motionless, its engineer having triggered emergency brakes, 2 more drones launched. The second operator struck the 6th car, approaching from the southeast under cover of smoke and flame. Despite distorted visuals, thermal systems locked onto the cooler metal body of the undamaged tanker. The shaped charge hit its mark, another 69 tons of diesel ignited in an instant. The third operator came in from the west, targeting the 8th and final car, still untouched. Another devastating impact. Another fireball. In less than 2 minutes, 3 coordinated drone strikes had ignited all 560 tons of fuel, creating a firestorm so intense it generated its own weather system. The blaze sucked air from the ground and sent a column of smoke and flame over 200 meters into the sky. The railway itself was rendered completely inoperable. Steel rails warped, wooden TIs incinerated, tanker car debris scattered like shrapnel. Russian repair crews will need weeks to restore this section, assuming they can work without being targeted again.